Okay, so skill number 9 is next. This is sort of a variation application related to transmissions, and what we're going to be sort of finding are different gear ratios that you would sort of see in a transmission. So in your transmission, right, as I understand it, you have a bunch of gears that you're sort of shifting through, and the higher the gear, right, allows your sort of car to go faster while the engine works a little bit less hard, right? Same principle as having gears on a bicycle, right? You need higher and lower gears so you can sort of get kind of more bang for your buck for each pedal. So what's happening in this section is sort of a nice kind of visual here to sort of show the way these sort of gears are connected. So in theory, you have an input gear. This is what we're going to be calling the driving gear. I'll kind of call it the input of the driving gear, DRVG for driving. So sort of coming from the engine, right, this sort of gear is initially turning. It's meshed with what would be then our sort of output gear, right, which would be our sort of driven gear, so the driving versus the driven gear. So your sort of force is sort of coming from here, the rotations are coming from here, meshed with this one, right, to sort of gear number 2, the output gear, and then out from there. The basics of this setup gets us a gear ratio that's really not any more complicated than just the output gear over the input, or what we would have in sort of the terms that we are using is the driven gear over the driving gear. So the gear ratio is sort of the output over the input, or as the book is putting it, the driven gear over the driving gear. Honestly, in this section, I think more than anything else, I mean, that as kind of a math setup is not particularly complicated. It becomes almost a little bit more of a language question, right? Or you're trying to just make sure that you have the right gear in the right position. This one has values synced up. You can sort of do this obviously by gear size, or also just by sort of the teeth, right? The number of teeth is sort of a stand-in for the size of the gear. So if this is a 10-tooth gear that's driving a 30-tooth gear, the ratio then is going to be, so 30 teeth is your output, right, coming from the 10 teeth. So 30 over 10 would be a 3-to-1 gear ratio, right? So that's sort of 3 turns of the first gear to get 1 turn out of the second gear. These are ratios, so a lot of the times what's going to happen here conceptually is you'll kind of do a division. It'll either come out to be a whole number or some sort of decimal number. It doesn't particularly matter. And the idea is you're finding what we would call a unit ratio, right? Which is where you have some sort of value and your second number is 1, right? So it's a something to 1 ratio. So you want your gear ratios to end up as a unit ratio where your second value is 1. All you need to do to achieve that is just do a division, right? Just divide and you get what you get. So let's take a look at the first example here in the book. So find the gear ratio for a 12-tooth pinion gear that drives a 54-tooth gear. So again, this is really all about just figuring out which is the input, which is the output. And it's about sort of doing this kind of language translation. So it drives the 54-tooth. So this is the driven gear, which means this is the output. The 12-tooth gear is driving, right? Is sort of the initial gear. So that means for our ratio, we're setting up the output over the input, which is 54 over 12. If we do that division, it's 4.5. So then the ratio would be 4.5 to 1, right? That's the basics of it. There's really not anything too more wild than that. It's all about just sort of getting these guys in the right position. In theory, it kind of makes a ratio. You could sort of say the output over the input should equal, right, the sort of ratio over 1. You could kind of set those up. I say that because I'd like to look at, well, we'll do a couple from the exercises. So I want to look at 1 and 7 first. We're going to also come back to this number 5. So number 1 in the exercise is, right, find the gear ratio of an 11-tooth pinion gear that drives a 41-tooth gear, right? Express using the Colwin notation, right? It is a ratio, essentially, is all that's saying. So my information here, right, my driving gear, my input gear is 11 teeth versus my driven gear, my output gear, right, my sort of gear number 2 is 41 teeth. So my ratio, I just need to do output over the input, so that's 41 over 11. If we just divide this, so 3.727, we'll call that 3.73. So then as a ratio, 3.73 to 1, right? So the gear ratio should be a ratio, hence, right, 3.73 to 1. So that's sort of 3.73 turns, right? 3 and just about 3/4 turns of the first gear to get 1 in the second. If we changed around a little bit, what we're asking for, so number 7 is a pretty similar setup. We're just given slightly different information. If the input gear to a transmission has 22 teeth, and the gear ratio is 3.5 to 1, how many teeth does the driven gear have, right? How many teeth does the output gear have? So number 7, let's try to put this information down. So input is 22 teeth. The output is question mark, but we know the ratio is 3.5 to 1. So the setup here, right, is it should be the output over the input to get our ratio. So what that means is I'll use, okay, so my output is X, my input is 22, and any ratio I can really write as a fraction, right? So that should essentially be equivalent to, you know, if my ratio is 3.5 to 1, that would be 3.5 over 1. I can really just solve this with a quick cross multiply, just like any good ratio. So X times 1, which is of course just X, should equal 22 times 3.5. Would be 77. So 77 teeth on the output, right? Simple as that. All I need to do, right, set this ratio up, and I can just do a quick calculation and be good to go. This is a shorter one. We'll do one more video for this skill that looks at sort of a sequence of gears. So that'll be next. We're technically not covering every single example from this section, but we're going to do one more short video. So it's coming up next.